All right, just a quick one. I've been setting this thing up because I wanted to use the good rotor again. So I've got a drive coil here with the JL94 circuit. There's my load with some drilled out plastic on it. And then here's my pickup coil. I haven't got it hooked up yet, but what I wanted to show you was that everything here is 3D printed. The mount for the coil here, 3D printed. The mount for this guy here, 3D printed. And the mount for the back coil. Here, hold on a second. Let me pause this. With this JL94 circuit, sometimes you got to get it going, but it's flying, and that's at 12 volts. Let's turn it down a little bit. My video turned off. I think I was talking about if I just put another screw in the back of this one here, it should stop the vibration. But looking good, huh? Everything is 3D printed. That's really what I wanted to show. But like I said, I'm going to have to get a good meter because I've only got a couple of cheap ones. My good one, I think either the battery's dead or it crapped. Shit the bucket. But mainly I wanted to show off the 3D printed parts. The plug to hold this guy up, the base here, the base here, the holder here, and I even made another one here. I don't know why I did that. It was for something else. Little aerial shot there. And what's nice about this is I can push it in, or I can pull it back like that. So I could really change the dynamics of the test once I get my meter set up. Anyway, just wanted to show you guys that. I know it's been a while, but you guys probably remember this rotor from before. G-Law got me thinking about it when he told me about his test he did with his spinning up for a really long time. And these bearings they spin up forever. And so it had me thinking about this rotor, how good it is, and how I wanted to get it set up. All right,